Hey guys, welcome back. Today we're going to start our last unit of the school year. We're going to cover two things, how to simplify radicals and then also the Pythagorean theorem. After you finish watching this screencast, then what you want to do is complete the classwork assignment, which is a Canvas quiz. And your benchmark this week, like I said earlier, is a little bit different. Your benchmark is that you successfully completed the two Canvas quizzes from Tuesday and Thursday. If you have any questions, feel free to email me. Any math questions, email me. Okay, so simplifying radicals. This is a topic that you might have encountered last year in Algebra 2. To be able to simplify a radical, you want to make sure that you feel comfortable with your perfect squares. So you might remember from my classroom on that column near the door, I had perfect squares and then I had the perfect cubes. So a perfect square is a square of an integer, meaning you multiply a number by itself. So my perfect squares are numbers like 1, 4, 9, 16, 25, 36, and so forth. The square root of a number is the side length of a square with that area. And taking the square root is the opposite operation of squaring a number. Just like addition and subtraction are opposite operations, squaring and taking the square root of a number, those are opposite operations. This symbol right here is called the radical, and it means to take the square root of whatever number is inside of it. The biggest property that we're going to need to simplify square roots is this property right here. It's called your product property, and you can use this property to condense or expand radicals. If you look right here, if you want to put together radicals, if you are multiplying two radicals, you can put them in one radical by multiplying what's inside of the radicals. So for example, down here, I have the square root of 4 times the square root of 9. What I can do is I can multiply 4 times 9 and put it inside one radical. I can also use this property to break up a radical, and that's what we'll do a lot of today. Now down here, when I multiply 4 times 9, I get 36, and the square root of 36 is just 6. Now over here on the left-hand side, if I were to simplify those radicals each separately, the square root of 4 is 2, and the square root of 9 is 3, and 2 times 3, that's also how I could get my answer. A popular question is, well, how do you know if your radical is simplified? How do you know if you're done? When you look at the number in the radical, if the only perfect square factor, so if the only perfect square that goes into that number is 1, then you have a simplified radical. But if you looked at your number and 4 could go in, or 9, or 16, or 25, you need to keep going. We're going to do a bunch of practice. So if you want to do the first two with me, and then you can pause the video and maybe try the others on your own. If you feel like you need to watch me do a bunch of these, then watch. On the right-hand side, here's my list of perfect squares. I usually, especially if I know that I need to simplify radicals, I like to write that list on my paper next to my work. So that's definitely a strategy that I would recommend. For the first radical, what we want to do is simplify the square root of 80. So when I look at my list, 80 would fall right here. I want to find the biggest perfect square factor. So I work backwards. Does 64 go into 80? No. 49? No. 36? No. 25? 16? Yes. So 16 times 5 equals 80. So you can use that product property to break up the radical. So here it is. There's the product property. You broke it up into two radicals. Now, strategically, you chose a perfect square factor because whenever you take the square root of a perfect square, it's just a number. It's just an integer. The square root of 16 is 4. And so my final answer, this radical completely simplified, is 4 root 5. The next one, the square root of 12. 12 would fall right here. So I work backwards. Is 9 a factor of 12? Is 4? Yes. So 12 I can break up into 4 times 3. Here's that product property, breaking up the radical. Square root of 4 is just 2. And the square root of 3, I can't simplify it any further, so it stays. So 2 root 3. That's how you read your answers out loud. Practice reading the answers out loud. Oftentimes, like in class, if we were in class, I'd find that a lot of you would hesitate to read it out loud. So really practice reading these radicals out loud. The square root of 50, 50 falls right here. My goal is to find the largest perfect square factor that goes into 50. 49 is not a factor. 36, 25, that is a factor. 25 times 2 gives me 50. And the square root of 25 is just 5. Square root of 32. 32 falls right here. I work backwards. 25 is not a factor. 16 is a factor. 16 times 2 gives you 32. So if I use my product property and break it up into the two radicals, square root of 16 is a perfect square. So I can write my final simplified answer as 4 root 2, or 4 radical 2, or 4 times the square root of 2. All different ways I can read that answer out loud. Next up, square root of 150. 150 falls right here. I'm going to work backwards. I'm going to find the biggest perfect square factor that goes into it. And so you can use your calculator to be crunching these numbers. 25 is the biggest. 25 times 6 gives you 150. Square root of 25 is a perfect square. So it's just 5 radical 6. Next up, square root of 18. 18 falls right here. Find the biggest perfect square factor, 9. 9 times 2. And the square root of 9 is just 3. So my final answer is 3 root 2. Square root of 200. 200 falls right here. I work backwards until I find the biggest perfect square factor. That factor is 100. 100 times 2. Square root of 100 is just 10. So my final answer is 10 radical 2. Next up, square root of 175 falls right here. Work backwards. Find the biggest perfect square factor that you can find. The biggest factor that goes in is the number 25. 25 times 7 gives you 175. Square root of 25 is 5. So I end up with 5 root 7. All right, let's see if you got this down. So I'm going to give you 30 seconds on the clock. I want you to simplify this radical. So square root of 75, what would that simplify to be? All right, let's see if you got it correct. So 75, you want to find the largest perfect square that goes into it. It's 25 times 3. And so the square root of 25, if you got 5 root 3, high five. Next up, we have the square root of 48. So I'll put 30 seconds on the clock. Simplify this radical. Square root of 48. All right, let's see if you got it. So 48 would fall right here. Did you find the biggest perfect square factor? If you did, it's 16 times 3. And square root of 16 is just 4. So if you got 4 root 3, you're 5. The last problem, this is square root of 64, this is probably the number one error that I see kids make when they're simplifying radicals. So I definitely wanted to make sure that we covered this. We'll see if you get it correct or if you make a mistake. It's okay if you make a mistake, as long as you learn from your mistake. Right, the time is up. Square root of 64, the number one incorrect answer that kids write is they write the square root of 8. No, if it's a perfect square, when you take the square root of a perfect square, it's always going to be just a number without the radical. So square root of 64 is just 8. The second half of today's lesson is on the Pythagorean theorem. So this you would have encountered in middle school. It is a theorem that only works on right triangles, so it has to be a right triangle. And it's a squared plus b squared equals c squared. C squared has to be the hypotenuse. It has to be that longest side. It has to be the side across from the right angle. If you find that you're getting some of these problems incorrect, make sure that you're identifying that hypotenuse correctly. And one thing that you can do is take your pen where that box is and draw an arrow across from it. So draw like an arrow across to that hypotenuse. The fire is back. These problems are hot. Okay, so number one, the first thing I do is it's a right triangle. I'm missing a side, so I can use the Pythagorean theorem. So this right here is my hypotenuse. So I'm going to set up my equation as x squared plus 6 squared equals that hypotenuse, which is 9 squared. I'm going to simplify each of my terms. 6 squared is 36. 9 squared is 81. I'm going to get x squared by itself by subtracting 36 from both sides. Now, your goal is to get x by itself. And right now, x is being squared. So you think, what is the opposite operation of squaring something? And it would be to take the square root of both sides. What you do to one side, you need to do to the other. Now, when you write your answer, we want to write it as a simplified radical. So I look at the number in my radical, and I can use those same strategies that we just did a whole bunch of times. Find the biggest perfect square that goes into 45, which would be 9. And the square root of 9 is just 3. So you end up with 3 root 5. Over here, first thing, identify that hypotenuse. So this is your hypotenuse. So you have leg squared plus the other leg squared equal to the hypotenuse squared. Let's go through and simplify each term. 9 squared is 81. This right here is very interesting. Make sure you take note. When you square a square root, they cancel each other out. So you're just left with 145. Get x squared by itself by subtracting 81. Take the square root of both sides, and this is one of our friendly perfect squares. Square root of 64 is just 8. The next two examples we'll take a look at this one. First thing I do is look at that right angle. The side across is that hypotenuse. So I'm going to do leg squared plus the other leg squared equal to the hypotenuse squared. Have it all set up, square those numbers, get x squared by itself, subtract 81 from both sides. Then you got x squared by itself, but what would x be? So take the square root of both sides, simplify that radical. So I look at the number 40, it falls right here, and I work backwards to find the biggest perfect square factor of the number 40. It would be 4 times 10. Square root of 4 is just 2, so my final answer is 2 root 10. Over here, first thing, it's a right triangle. I know that I can use my Pythagorean theorem to find that missing side. This is my hypotenuse right here is x. So when I set up my equation, I'm going to have 4 squared plus 4 squared equals x squared. And I'll simplify these terms. 16 plus 16. I want to get x by itself, so I take the square root of both sides. 32, I want to simplify the square root of 32. Would fall right here, work backwards. The biggest perfect square factor of 32 would be 16. And so the square root of 16 is 4. So my final answer is 4 root 2. You might be asked to figure out if a triangle is acute, right, or obtuse, and you can actually use the Pythagorean theorem to figure that out. C squared has to be the biggest number. So you're going to be given 3 numbers. You want to first identify which of those 3 numbers is the biggest. Circle it, highlight it, underline it, do whatever you got to do, but you need to find the biggest number. If that biggest number is greater than the other 2 numbers, when you square them and add them each together, it is an obtuse triangle. If that biggest number squared is less than the other 2 numbers, each individually squared and added together, then you have an acute triangle. And if a squared plus b squared equals c squared, well, you just proved the Pythagorean theorem, so it works out. For part A, I underlined the biggest number. So I'm going to do 14 squared. And then I'm going to just think about, well, what are the other 2 numbers? What do I get if I square those numbers each and then add them together? So 14 squared, I get 196, and that is bigger than the other side of a squared plus b squared. So that means I have an obtuse triangle. On part B, the biggest number is 25. So I take 25, I square it, and then I take the other 2 numbers, I square each of them and add them together. And now c squared is equal to a squared plus b squared. So that means it is a right triangle. For the last one, if one of your answers is a radical, then what you can do is you can go to your calc just to kind of see like what is the square root of 11. So it's about 3.3. So it's not the biggest number that was given to me. I need to find the biggest number. That's my C. So I'm going to have 5 squared. And again, when I square a radical, the radical and the exponent cancel each other out. And so you're just left with the number that's inside. And because c squared is less than a squared plus b squared, that would make it an acute triangle. So note in your notes, when you're given a type of question where you're asked to classify, you're going to be given 3 numbers. You need to first figure out what's the biggest number. That always has to be C. And the other 2 numbers, it doesn't matter which one you call A or B. Okay, the last there's 2 more. So when you buy a television, it's measured by the screen's diagonal length. So like a 30-inch TV, that's the length of the diagonal. So if the diagonal of this TV is 52 inches and the width is 40 inches, what is the height of the TV? So this is a rectangle, so we can use the Pythagorean theorem because this is a right angle on this triangle. So when I plug in my values, I've got x squared plus 40 squared equal that hypotenuse, which is that diagonal, which was 52 squared. Use your calculator because it says round to the nearest tenth. So all throughout this, I'll be using my calculator. I'm going to square 40. I'll square 52. I'm going to get x squared by itself. And I want x by itself, so I'm going to take the square root of both sides. And so because the directions say to round to the nearest tenth, that's when you would go to your calculator. And to the nearest tenth would be 33.8. 2 inches. All right. So this one you got a baseball diamond is a square with 90-foot sides. Home plate and second base are opposite vertices of the square. About how far is home plate from second base? So if you look, this is a right triangle. We know the 2 legs. We're trying to find the hypotenuse. And because it says round to the nearest tenth, you're using your calculator to get the decimal. When I plug it into my Pythagorean theorem, I have leg squared plus leg squared equals the hypotenuse squared. So I plug 90 squared plus 90 squared. I evaluate each of those numbers. I add them together. And I want to get x by itself, so I take the square root of both sides. Again, you're going to your calculator because it said to round. If it didn't say to round, then you would be simplifying your radicals. So the nearest tenth would be 1 decimal place. So it would be 127.3 inches. Or not inches, it should be feet. Let me fix it. All right, and that is it for today. So on Canvas is that problem set. So you want to complete that again. Remember, you have unlimited tries to get a passing score on it. And I mean, keep trying until you get a good, decent score for sure. Keep pushing yourself. If you have questions, email me. What else? And this is our last unit. This is a very big, important unit for those of you that are continuing on to pre-calculus your senior year. Even some of you, whatever your interests are post high school, if you plan on going to college or anything like that, trigonometry is a big unit. So really make sure that you push yourself these last couple of weeks. If you want additional practice, reach out to me. Anything I can do to help you, let me know. Have a great day, guys. Bye.